We're asked to solve the quadratic formula 2n squared equals negative 8n minus 5. Step 1. We were told to use the quadratic formula to solve the equation. Solve with the quadratic formula. Step 1. Get equation that's given to us into the proper form. an squared plus bn plus c equal sign 0 on the other side. Do you see how that's not the form of the question? It's screwed up. It's 2n squared equals negative 8n minus 5. We have to move the negative 8n and the negative 5 over to the other side in order to get 0 alone on the right side. So when we do that, this equation becomes 2n squared plus 8n plus 5 equals, what's left on the other side is 0. When we add this 8n and negative, we add 8n and 5 to both sides. Okay, now we're ready to solve the equation using the quadratic formula. Now, in order to identify the a, the b, and the c, we have to compare our 2n squared plus 8n plus 5 equals 0 to a times n squared plus b times n plus c equals 0. Compare these two, and it gives us a is the coefficient of n squared. It's 2 in this proper form. B is the coefficient of n. It's positive 8 in this form. And c is the coefficient at the end. It is positive 5 when it's written in this proper form. So these guys are the values we're going to plug into the quadratic formula to solve the equation. This formula will give us the n value that satisfies this given equation. Step 3, write the quadratic formula. Okay, we're looking for n, the solution to the equation. N, according to the quadratic formula, is equal to a long line, negative b, plus or minus a long square root of b to the second power minus 4 times a times c, all of that over 2 times a. We have to have this memorized to be able to use it. And we can only use it when we have the equation given to us or written in the proper form. an squared plus bn plus c equals 0. Now it's quite possible that the coefficients a, b, and c could be negative when you move them all on one side. If you moved everything over to the right side and the left side was 0, that's okay. All of your coefficients are negative, but guess what? When you simplify your answer, it will be the same as mine. I just like working with the first coefficient of the n squared dude. I always like him to be positive. It's easier for me to use the positive coefficient being the first one. Okay, now I'm going to insert the values here for a, b, and c into the quadratic formula. N equals long line, negative parenthesis, plus or minus square root of parenthesis squared minus 4 times parenthesis over 2 times parenthesis. Now in the first parenthesis we have a b, that's positive 8 in the parenthesis, and here also positive 8. Then the next parenthesis after the 4 is the a value, that's a 2, and after that we have the c value, which is a 5, and down below we have the a value, which is 2. Now comes the work. This is where all the work is involved. Simplifying this n value. N is equal to negative 8 plus or minus square root of 64 minus 2 times 4 is 8. 8 times 5 is 40. 64 minus 40. And all of that over 2 times 2. Let's leave that as 2 times 2 for a minute. Just leave it like that. And some more simplifying. That's negative 8 plus or minus square root of 64 minus 40 is 24 over 2 times 2. Okay, so that's equal to, well, let's see. The next thing we need to do is simplify the radical. Is there a perfect square factor embedded in the number 24? And the answer is yes, it's a 4. So we can bust it out. Negative 8 plus or minus the square root of 4 times the square root of 6, because 4 times 6 is 24, over that 2 times 2 on the bottom. I'm leaving it like that for a reason. Okay, let's go ahead and simplify the square root of 4. That's 2. So it's negative 8 plus or minus 2 times the square root of 6 over 2 times 2. All we did in this step was replace the square root of 4 with 2. Okay, that's what it's equal to. It's equal to 2. Okay, now I'm ready to cancel the top and bottom. I have a single expression on the top, a single expression on the bottom. I chose not to bust it apart. You may choose to bust it apart. I chose not to. I chose to leave the top as a single expression and the bottom as a single expression. So let me factor a factor out of the top that can cancel with a factor on the bottom. I see that there's a term negative 8 and then there's a term 2 times the square root of 6. What is the greatest common integer that those two values share? It's the number 2. And that's the one I want to pull out because there's a factor of 2 on the bottom. It leaves negative 4 on the top because 2 times negative 4 equals negative 8. Then the plus or minus, and then it leaves the square root of 6 because 2 times the square root of 6 is 2 square root of 6. And all of that is over 2 times 2. Now cancel a common factor of 2 on the top and bottom, and your answer is negative 4 plus or minus square root of 6 all over the number 2. Now that is correct. That answer is correct. There's no reason for me to break it apart. If you want to break it apart, go for it. You could have broken it apart earlier. That's fine too. If you did break this apart, you could write this answer in this form. Negative 4 over 2 plus or minus the square root of 6 over 2. And then you would simplify the first term, negative 4 over 2, to negative 2 plus or minus 1/2 times the square root of 6. Or you could write it as the square root of 6 over 2. Now this answer is correct. It's acceptable. It just took a few more steps to do it. You might have done it earlier. That's fine. These are both the same answer. So it really doesn't matter which one you give me. Give me the first, give me the second. I like the first one better because I don't see any individual fractions in front of the square root. The second answer has like a 1/2 multiplying the square root, but who cares? What the heck? These are the same answers. Everything's good. Now, if you still have a problem understanding what I did here, come back now and post a question. If it makes sense, let me know. Thank you.